I hope this MS Word document is visible. Is it visible? Document?
Yes, sir.
Okay. So in universal testing machine, you are conducting around 4 tests. One is tensile, bending. Tensile you are already finished. One more is bending. That also you have finished. Then compression. For one for brittle material, one more for ductile material. That also you have finished. Only one experiment is pending with respect to universal testing machine or UTM. That is shear strength. I think example for the shearing force is, suppose we want to cut the book. If you pull the book, it will not cut. If you apply any compression load, even tons of load, it will not break. Only if you tear it, so then it will break. Or by using cut a small scissor, we can cut the book. Because when you use the scissor, so it will apply shear load or shear stress, not compression load or tensile load. Even hair cutting or paper cutting, even sheet metal cutting in automotive body industries or aircraft industries, sheet metal works. So all will comes under shear loading. So now you can see here already similar type of arrangement is there in our UTM. Imagine this is the specimen. So this middle one is specimen. So when it is centerpiece is through the centerpiece you are applying the load. So only that interface, there is a small gap there. In that particular portion is subject to shear loading. So already you have studied and then this riveted joint in your machine drawing. The riveted joints are subject to shear loading, and it may be subject to single shear or it may be double shear, depending upon the number of plates you are keeping. So it may be subject to single shear or it may be subject to double shear. If only one cross section area which resists the loading, then it is referred as single shear. If two cross section area, here you can see right side diagram, between B and C there is a small cross section area, so it will resist the applied load. Between C and D there is one more same specimen, there is a small cross section area which will resist the load, then it is referred as a double shear. But if you consider the shear stress formula, force divided by shear area, for the first one, suppose the area of the specimen is A, then for the first one, the shear stress is equal to force divided by A. What about for the second one? What is the formula for shear stress for the double shear? For the second diagram, what is the formula? In the first diagram, only one cross section area, this is the cross section between B and C. So this cross section area is parallel to cross section. For the first diagram, shear stress is equal to force divided by area is equal to A. For the second diagram, there are two areas which resist external loading. One area is between B and C, that is related to A, and one more area between C and D. There's one more area that is again it will be A only. Then what is the shear stress formula for the second diagram? Double shear. The riveted joint in my machine drawing, you are doing no single shear, single plate, multi plate, 2 plate, 3 plate. What is the formula for a double shear? What is the shear strength? Force divided by 2A for the second diagram, because there are two areas which resist applied load. For the first diagram is considered, so it is only one area. And if you come to, so this is the example you can see. Can you see these photos? Yes or no? Can you see these photos?
Yes, sir. Yes, sir.
Okay. So here you can see, no, this is the actual photograph. This is not schematic sketch. This is a bolted joint. So between top sheet and bottom sheet, this is you have the bolt. Bolt is subject to shear. Between top sheet and bottom sheet, bottom plate and top plate, there is a small gap. Is there? Through this gap, the bolt may shear off. That is referred as single shear. If you come to see here, this is the one more diagram. That same diagram we have shown. The only bolt is shown here. So top side, one force is applied in one direction. Bottom side, one more direction is force is applied in another direction. Because of that, shearing takes place. Like two blades of the scissor. The direction of movement of the two blades of the shear or scissor are not same. One is moving in the downward direction. One more is moving in the upward direction. One force is applied in the downward direction. One more force is applied in the upward direction, or two opposite forces. So same, the schematic diagram is shown here. The two opposite forces are acting here. And finally, the bolt is shear off. This is a single shear, only one cross-section area which resists external loading. Then it is referred as single shear. These photos are available. The how exactly you are keeping a specimen in a UTM is given by this diagram. This diagram. This is the specimen, and load is applied through this arrangement. That you can see the video. Now this is the double shear. You can see here I think in the machine drawing you have seen. So this is the bolt. Imagine B and A, plate B and A. I think you can understand because already you studied machine drawing. The plate B and A, those are the plate to be joined together. For that you are using plate C and D. Plate C and D are not are used for joining plate B and A. Our aim is to join plate A and B. For that you are using two more plates C and D and two bolts. You can see here this is a one bolt and this is one more bolt. Number of bolt is not important. There may be set of blade bolt. So now you can see here between the plate B, you can, if you see from the top, there is a one shear area. We can see this diagram. We can see bottom diagram. So one force is acting in the left, from right to left, towards left side. That is from the plate C. And one more force is acting from plate B. That is towards right. And one more force is acting from plate D. That is towards left. That's why they are given FD, FC, etc. So finally, once you apply huge amount of force, the bolt will shear off. The top portion here, what will get one shear and one more shear, one more cutting here. The finally end with one small piece. We'll end with three pieces. In simple way, we'll get three pieces: top piece, bottom piece. In between, there is a one more piece. So that is, so top area we can see here P. So there is this is a top surface area which oppose the external loading, and bottom surface area which oppose the external loading. So together there are two areas which oppose external loading. Hence, the for the double shear, the shear strength is equal to 4 divided by 2A. For the double shear, the shear strength formula is force divided by 2A. So now here also you can see as for the single shear and double shear. The first one is single shear. Imagine you have the specimen, so it is sheared at the midpoint. Here it is a double shear. Second diagram is for the double shear. So this is the arrangement how the shearing takes place here. So this riveted joint already you have seen in machine drawing. This is the single shear, and here also it is. You can see here the shear. You can see that diagram rightmost. We have rivet. It is sheared or cut at two places. This is one place and one more bottom place. So procedure I will tell you. I am not going into details because you can see. So when you come to observation, you have to note down the material. Material is normally mild steel. So you have to note down the diameter of the specimen because we have to find out the area. For that you require a diameter. We need to find out what is the initial area of the specimen. Once you know the initial diameter, average diameter is nothing but the initial diameter. So finally you have to find out initial area. You have to find out, that is calculation part. and what is the maximum force you have to note down. No need to note down all forces, only you have to note down the maximum force. As per observation is considered, you have to note down the initial diameter. From the initial diameter, we can get initial area. The force divided by initial area gives the shear strength for single shear. Force divided by double 2A give the shear strength for the double shear. Here you can see a single shear and double shear. Finally, you have to note down. And formulas are very simple. The shear stress is equal to tau max. Tau is equal to F max divided by A for the single shear. For the double shear, shear stress is equal to F max divided by 2A. That is the only difference. Then these are the regular Viva questions. So you see the video of
these are the pictures for single shear. We have one more set. This is for the double shear. So it's a single shear attachment. This is double shear attachment. It's a material. It's a white sheet. First to take.
For the single shear test, there is an attachment is different. For the double shear test, again attachments are different because how the specimen is holding, that is totally different. That you have to remember. This is the specimen. There is a cylindrical specimen. So as usual, you have to measure the diameter.
MSR 11, CVD 48 newtons. So this is diameter. So material.
So way out to measure the diameter is we required initial area of the specimen to get the shear strength. So left side is the single shear attachment and right side component is the double shear attachment.
Bushes is there. Bushes diameter 12 mm is there. First you will check it. Diameter easy and positive. All the bushes there. This also will check it. After you fix it.
So that bush, the whatever the specimen you have prepared, it should go into the bush without much the clearance. Otherwise, instead of applying shear stress, shear loading, it may subject convert into bending load. That's why that gap between the two different plates and diameter of the specimen, diameter of the bushes, those things are very important. Everything is standardized.
And again, you'll insert, you see, single shear attachment. Fix it. Fix it. Again, on bottom side, one bush is there. After UTM mission, so
after mounting the specimen in the attachment, single shear attachment, then you have to keep this attachment in the UTM to apply the load. In the UTM, no need to note down each and every load. Only final load you have to note down. That is F maximum you have to note down.
UTM mission, bottom side, you fix it. Upper compression pad is there. After the zero stress testing machine. So right side now close. Right side now close. Switch on. Again.
All procedure for applying the application load and hydraulic loading system, everything is same, no difference. What you have procedure you have conducted, used for compression test, bending test, tensile test, same procedure you have to follow. So when you are operating the UTM, there is no much difference.
And cross it downwards just 1 mm, 2 mm to adjust. Cross it 1 mm, 2 mm to adjust. Again, switch on it. On right side, this is circuit 0.
So again, after switching on the machine, you have to set the indicator. One is deformation, one is displacement, one more is force. That you have to make it 0, same as other test.
Again, slowly release specimen. Friction, your compression for close it. That time, displacement 0.1 will come. That time, reset gear start. See, slowly. Okay. So reset gear start. Reset gear come. Only load. Shear load.
So we're not able to see.
So load 0.5 kilonewton. Again, maximum load is not suddenly decreasing. Maximum load you will take. That time is shear. It's a single shear.
So no need to note down all the forces here, force and displacement. Only final load you have to note down. We don't want any displacement. You are not finding out any strain. Just you are finding out only the strength. Strength is nothing but force divided by the maximum force that material can withstand divided by area. Is it video is visible? Is the video is visible? Yes or no?
Sir, can you play, sir?
Is it visible?
No, sir, it's black screen is coming.
You have to tell, no? Otherwise, how do you know that?
Sorry, sir.
Now visible?
Yes, sir.
Yes, sir.
You have to tell if video is not visible.
Double shear. So it's a single shear.
So there are two attachment here. One attachment for single shear and one more attachment for the double shear.
These are the fixtures for single shear. Next, we have one more set. This is for the double shear. So it's a single shear attachment. This is double shear attachment. It's a material. It's a mild steel. First to take initial diameter. First MSR 11, CVD 48 newtons. So this is diameter. So material mild steel tape. After the attachments is the single shear attachment and double shear attachment. Single shear attachment is the bushes is there. Bushes diameter 12 mm is there. First you will check it. Diameter easy to pass it. After four bushes there. This also will check it. After you fix it. And again you will insert. You see this is single shear attachment. Fix it. Fix it. Again on bottom side, one bush is there. After UTM mission, so universal testing mission.
First, you have to mount the specimen in the attachment. After mounting the specimen in the attachment, then you have to keep the complete set in UTM machine for for application of the load.
UTM mission, bottom side, fix it. Upper compression pad is there. After the universal testing mission. So right side of the load, left side of the load, switch on it. Again.
All procedure used for operating the UTM is same as compression, tensile as well as bending test. I will not repeat the same thing.
Left side of the load, hydraulic side will check it. Again, on mission, and cross it downwards just 1 mm, 2 mm to adjust. Cross it 1 mm, 2 mm to adjust. Again, switch on it. Right side. This is subject 0. Again, slowly release it. this one, fixation your compression part goes into that time displacement point 1 point will come. That time reset case start.
So once it start deforming, then you have to set it by using tear button so that we can make it 0. Then afterwards you can note down the reading, but no, you are not noting down all the readings, only the F maximum load it takes before it shears. Only that particular load you are taking, not all loading. You are no need to find out stresses, different stress value, different strain value, etc. No need to note down deformation value also. Yeah.
See, slowly, so reset, then start. Reset will come. Only load, shear load you will take. So load 0.5 kilonewton. Again, maximum load is not suddenly decreasing. Maximum load you will take. That time is shear. This is single shear.
Even though you are applying compression loading, the finally load acting on the specimen is single shear. The shear load is applied. Don't think that you are applying compression load. Though you are applying compression load, internal, because of the internal arrangement and bushes, etc. Finally, load acting on the specimen is shear load, not compression load. That you have to remember. This is only the application load. I'll little bit go fast. I think. No.
Yes.
You know? Mobile in that one.
Single shear. So one shear is there. So 144 single shear. Maximum load. This is single shear.
You can see here earlier there is a single specimen. Now it is sheared off into 2 pieces. That is for the single shear. If it is for the double shear, then initial one specimen is sheared into 3 pieces. That is the major difference between single shear and double shear. Now you are going for single shear test is over. Now you are using the double shear attachment to conduct the shear strength.
Same procedure. First we will take material milestone, MSR 11, CBD 48 users. So material milestone, after bushes is there, on time we check it. So if the bushes is there, this is insert. So if this round hole is there, a small thickness is upwards, it's a downwards. Insert. Again material will take. First insert. Again this side also. After bottom side you'll check it, gap is there, no? Bottom side. Again fix it, apply the load. So double shear type, bottom compression pad, we'll use it. Bottom compression pad, we'll use it. See, we'll fix it. This position. After same procedure, you apply the load. So first right side of close.
The remaining procedure remains no changes, same as your single shear, same as compression test or tensile test, same thing. I will go a little bit fast. So still you are applying the load. Still it will take the load. So whenever specimen breaks, suddenly load decreases. That is the indication. Specimen is already broken into 3 pieces.
Attachments. Remove it. Remove this. This is there. So double shear means
In double shear, we can see the specimen is sheared off at 2 places. Hence, initially we have only one specimen. Now one specimen is sheared into 3 pieces.
observe. So this thickness, see, this is double shear. This is a double shear. This is a double shear experiment.
That is finishes single shear and double shear. The simple formula: single shear is given by F max divided by A, and double shear F max divided by 2A, because 2 area which resist applied load. And you have to note down only the final maximum force. No need to note down the deformation, different forces, etc. No need to find out stresses, etc. Only you have to find out final strength. Now one more test is wear test. So can you give some example for the wear? Practical example for the wear. Can you give some example for wear? Can you give some example? If you use the cricket for a ball for a longer period, then it will wear out. Even our chappals or shoes, the sole, bottom part will wear out. Those are the regular domestic and other items. And if you consider the tire of the vehicle, that will wear out, then you have to replace the tire, or you have to go for retreading. So those are the example for the wear. Even shafts will wear out, bearings will wear out. So now we require to find out what is the wear rate. How much? What is the wear rate? Wear divided by time taken is nothing but a wear rate. Now, as this is a simple experiment, imagine you have to weigh the specimen before putting the specimen in the wear testing machine. Imagine if you run the machine for 10 hours, around 30 minutes. After it will wear, specimen will wear out. So once specimen is wear out, then again you have to take out the specimen. You have to measure what is the weight. Difference in weight gives the total amount of the wear. Total amount of wear. There is some disturbance. I hope you understood. There is a wear rate. Imagine you are putting the. Imagine we have the one tire. You are mounting the tire on the truck. Before mounting the tire on the truck, you are measuring what is the weight of the tire. Only tire, not wheel. Then after few year, 2 year or 3 year, you are taking out the tire. You are clean it. Once again, if you measure, suppose today tire weight is around 200, let it be around 100 kg, not 100, around 50 kg. After 2 year, weight may be reduced to, instead of 50, it maybe comes down to 49 because of the wear. How many years it took? 2 years. That is, initial weight is 50 kg. The final weight is 49 kg. Divided by 2 year. 2 year you can convert into hours or we can convert into minute. That is the basic principle used in wear testing. Our simple example is a simple engineering example if I give. So imagine you have the ball bearings. So if it is ball bearing is mounted on some fans or some devices. Before mounting on the devices, we have to note down the weight. Let it be weight is around 10 grams. It will run for a few years. After 2 or 3 years, we can take out the bearings and we can measure. If we measure instead of 10 grams, we may get only 9 grams. The wear total amount of wear is 10 minus 9, that is 1 gram for 2 years. 2 year means we can convert into seconds or minutes. That is wear rate is nothing but wear divided by time. That is nothing but wear rate. So what we are using is pin on disk machine. You can see the actual machine later. So this is the model of the machine. This is the dimension of the machine. When you come to observation, again the material you have chosen may be aluminum or steel. You have to note on the diameter of the specimen. There is a timer is set, whether you set it for 30 minutes or 20 minutes or 15 minutes, because you have to find out timers you have to mount. When other things are material, tabular column is considered, load in kg and speed and time in second, weight of the specimen. Finally, we are interested in the what is the initial weight and what is the final weight. The initial weight minus final weight divided by the time in second, that gives the percentage of wear. Multiplied by 100, that gives the percentage of wear. That is initial weight minus final weight divided by the initial weight into 100, that gives percentage of wear. Suppose we want wear rate, then you have to divide by time. I hope you understood wear and wear rate. The wear means the initial weight minus final weight, that is the nothing but wear. The percentage of wear is the initial weight minus final weight divided by initial weight into 100, that is percentage of wear. Suppose we want wear rate, then initial weight minus final weight divided by time, that is you can get it from the digital display, how much amount of time you've taken for that particular wear. The percentage of wear, this is the formula is already here, W1 minus W2 divided by W1. W1 is initial weight of the specimen. I have given the example of tire as well as bearings. W2 gives the final weight of the specimen. I have given the example of bearings as well as tire after wear out, and divided by the original dimension. And wear rate, the difference in weight you are getting in terms of gram divided by time. T you can see here. The wear rate, unit of wear rate is gram per second. The unit of wear is only gram. Percentage of wear you are getting in terms of gram, not just we are getting percentage. But when you come to wear rate, so you are getting in terms of second, grams per second. That means when you come to observation, you have to note down two things. One is initial weight of the specimen before it wear out, and final weight of the specimen after wear, then time taken. Any digital display is there, note on the time in second. These are the basic concept. Then I'll show the video. This information is available. What I am showing, this information is available in your manual. ಊಟ ಮಾಡಿದಾರೆ ಊಟ ಮಾಡ್ಕೊಂಬರಪ್ಪ.
So model.
The video is not seen.
Just I am opening.
201 say this is material fixing. First material fixing. This is disk is there. So hard disk. Next load. See maximum 10 kg is there. 5 kg, 2 kg, 2 numbers. So 1 kg, 1 number is there. After this the load is fixing this point. After the fixing specimen before this one. Again So model where test will be for this. Again, this is compound where is the machine. So model.
This is the wear testing machine. You are mounting the specimen in the top and bottom there is a disc. Your specimen is like a pin, and as disc rotates and in contact with the pin will wear out. You are measuring the wear out of the pin. That's why it is referred as a pin on disc wear testing machine.
Wear and friction machine monitor TR201 say.
That is the machine model. Don't worry about the model of the wear testing machine.
This is material fixing.
So here you can see here the top material is mounted, and when this specimen is directly contact with this plate, disc rotates. As disc rotates and directly in contact with the specimen will wear out.
First material fixing. This is disc is there. So
the bottom part is disc.
All disc. Next load. Say maximum 10 kg is there. 5 kg, 2 kg, 2 numbers. So 1 kg, 1 number is there. After this, the load is fixing this point. After the fixing, test will be for this one. Again, this is compound where is there, frictional force is there, or speed is there.
There are two set of experiment. So one set of the experiment is there are two cases. One is you are keeping the load constant. Suppose you are keeping the load of 10 kg. Let it be 1 kg, and we can vary the speed. We can run at 500 rpm or we can run at for 5000 rpm. If speed increases, the wear rate also increases for the given loading. The load is fixed. As speed increases, the wear also increases. There's a one set of experiment. And one more set of experiment is you are keeping the speed constant. Let it be around 500 rpm. You are increasing the load by 1 kg, 2 kg, 3 kg. As load increases, that definitely the wear rate is more even for the constant speed. Two set of experiment. One is load is constant. You are varying the speed. And one more set of experiment, the speed is constant, you are changing the load, and correspondingly you are measuring. So what is the initial weight of the specimen, what is the final weight of the specimen, by using a digital weighing balance. And digital indicator gives the total duration in terms of second. From that you can get wear rate. That's why you have digital indicator. You are not noting down any things here. So everything is fixed now. This for only what is the amount of force applied, all those, what is the status of the loading, that will shows. No need to note down any values here.
Time will set at 3 minutes second.
We can set the time for 3 minutes or 5 minutes or 10 minutes, that depending upon our convenience.
Speed 500 rpm will set it. First say material.
This is the digital weighing balance. It is a very high accurate weighing balance. It is not weighing balance what you are seeing in the regular grocery stores. Is accuracy is around 4th digit. I think we can measure the 1 kg, 1.0001 kg. That means up to 4th decimal. The regular weighing balance that is there is available in regular shops, maybe cost around 2 to 5,000 rupees. This costs around 1.2 lakhs rupees because of high accurate weighing balance. It is made using German technology.
So aluminum. First you will take.
Why you have to measure is to find out where we require initial weight and final weight. So before putting the specimen in the wear testing machine, you have to note down initial weight, and afterwards you have to measure the final weight.
First we'll take initial diameter. So 12.597 initial weight. So initial weight will take after specimen. So it fix it.
After measuring the initial weight, you have to mount the specimen in the pin on disc machine. You can see here he is trying to mount.
Allen kit 2.5 Allen kit. So fixed jaws is there.
After inserting the specimen through that small hole by using Allen key, you have to tighten the specimen.
So material, not stopper piece is there. We'll fix it stopper. Again, fingers is there. No, this finger is upward. This is the material. Is a downward. Say this is upwards. This is downwards. This finger is upward pressure. This is downwards. After this is tighten. Specimen. We'll fix it. Allen screw. Tighten. So this is ordinance EM31 material. So next this is crack radius. The specimen center.
We can see here, this is the disc. Only disc rotates indirectly in contact with the specimen. As disc rotates, the specimen wear out. That we need to find out.
So the center is a crack radius. So 40 mm crack radius is there. After scale is there. Crack radius 40 crack radius is. After is a load is there. So two experiments will come. One is load constant, speed vary. Another.
As I had already discussed, there are two set of experiment. One is load is constant and varying the speed, and one more case, the speed remains constant. You are varying the load. So varying the load, we have arrangement here. So you can see.
Speed constant, load vary. So first speed constant 500 is there. Load variable. So time 3 minutes. So under first load specimen switching after apply the load. So 3 kg. Apply the load 3 kg. Again stopper piece is there. You remove it. So after switch on this machine. So time is 3 minutes. You set it. So already circuit.
We fix the time, that is 3 minutes. We fix the load 3 kg. Now you are switching on the machine.
RPM 500. Switch on this machine. So then so we completed 3 minutes of running condition. So remove the load. Again, we'll fix it. Specimen, you remove it. Specimen.
After 3 minutes, you have to remove the specimen and you have to measure the final weight of the specimen.
Remove it. Again, weight you take. First already initial weight you take. Okay. Final weight you take. Final weight you take.
ಪ್ರಸನ್ನ
Final weight.
ಊಟ ಮಾಡೋದಾಗ ಮಾಡಿಬಿಡ್ಬೇಕು ನನಗೆ 15 ನಿಮಿಷ ಇದೆ ಮಾಡ್ಕೊಂಡು ಬಂದ್ಯಾ
Same procedure times 3 minutes speed 500 constant load 4 kg. Again stopper will fix it. Again will fix it. Specimen.
And same set of experiment is conducted for different loading condition. No much difference.
Stopper you will remove. So same procedure times 3 minutes speed 500 constant load 4 kg. Again stopper will fix it. Again will fix it. Specimen. Again load.
You have to mount the specimen properly. There should not be any slackness. If any slackness, that will give the wrong values, wrong wear rate and wear.
4 kg. 4 kg.
In the previously applied 3 kg, now you are applying 4 kg. Then you are finding out what is the wear rate for 4 kg.
So speed constant. So stopper you will remove. Again start. Again 3 minutes.
So you can see there's a disc. As it disc rotates, so it is directly in contact with the specimen. Because of the direct contact and sliding contact, the specimen wear out. That wear and wear rate you are going to find out by using this equipment.
So again, remove this load, proper fix it.
After 3 minutes, again you have to remove the load. Then you have to weigh the specimen.
Suppose specimen you have removed. Specimen you have removed. So same procedure. Again, we take it weight. So final weight you take. Okay.
Finally, you are measuring what is the initial weight as well as the final weight. The difference between initial weight and final weight gives the wear. Divided by time, 3 minutes or 3 into 60 seconds. That gives the wear rate.
Same procedure. Stopper and fix it. Okay. The finger is upwards, is downwards. Again, slide it, specimen. Again, first 2 kg, 3 kg, 4 kg, again, fix it 5 kg.
For the first, we have applied only 3 kg of load. The second experiment, we applied only 4 kg of load. Now you are applying the 5 kg of load, but speed remains constant, 500 RPM. That is the one set of experiment. In one more set of experiment, we can fix the load, let it be around 1 kg. We can change the speed 500, 1000, 1500 or 2000 like that.
5 kg. So again, start. Take this 3 minutes. So remove the load, 5 kg. Again, stopper and fix it. Again, specimen, you remove it. The same procedure. Remove it. Weight you check it. Final weight. So this is speed constant, load variant. Speed constant, load variance. Again, same procedure. Load constant, speed variant. Load 3 kg. Speed.
The one set of experiment, what you have done is you fix the load, fix the RPM, that is 500 RPM, and we varied the load 3 kg, 5 kg, 4 kg, and 5 kg. That's one more set of experiment is you are fixing the load 3 kg, you are varying the speed 500 RPM, 1000 RPM, 1500 RPM like that.
These are the pictures for single shear.
If you have any doubt, you can clarify. We have finished 2 experiments. And today or tomorrow are giving second between what are the experiment you have finished between first test and second test, you finish it. And within this Saturday evening or Sunday evening, you have to upload into Google Classroom or create special assignment space in Google Classroom. But be ready. Whatever the experiment we finished between first test and second test, you have to upload within this Sunday, coming Sunday. I'll give sufficient time. So we have to finish it within coming Sunday. Those I hope others, only few students are not finished the first set of experiment. Those experiments conducted between before first test. I hope everyone is uploaded. Only few are left out last week, but I don't know what is the status today. So start writing the record and finish it. And anyhow, I am creating a special assignment space in Google Classroom for a set of experiment we conducted between first test and second test. So please enter your USN number and name. If you have any doubt, you can clarify. Otherwise, you can leave now. Enter your name and USN number.
Thank you, sir.
Okay. Welcome.
Thank you, sir.
Sir, I applied leave because I am not feeling well. My knee joint injured, but still I am taking classes from the home. Also, not enter your USN number. Please enter before leaving. Abhishek Joshi, you have any doubt? Abhishek? Bhanu Pratap?